on the topics of elasticity on the globe. My name is Đinh Trung from Vienna University of Technology, and I'm supposed to be monitor all the talk today. The first talk will be by Pablo Fernandez from University of Sevilla on the topics of SLA, and hopefully you give us something about whether SLA is still okay or is already dead, and now changing to elasticity or not. So welcome.
Thank you. Thank you very much. I think this is going to be the first time I have a presentation with this. It feels like a singer. Well, as Lin was saying, I'm going to try to defend the idea of SLA. I will see if I can survive or not. So basically, my presentation is divided in very well-defined two parts. First, about the foundations of what we believe is the SLA, and I'm going to present the work that we have been doing in the last years. And the second part is based on this foundation, what we believe that it could be interesting to go for the elastic computing. And specifically, I'm going to show you a couple of practical implementations that we have done, and also some ongoing work. So because the first time here in the summer talk, I'm part of the ISA, that is Ingeniería Software Aplicada in Spanish, that is Applied Software Engineering, that is led by the Dr. Antonio Ruiz Cortés. And we are this group of people. This is an old picture of us. We have grown since then. And I'm going to start actually with a slide that was stating the actual elephant in the room. That is, what is actually an SLA? Because at the end, SLA has been a very overused term in several scenarios, several domains. Many people give different semantics. So what I'm going to show you now is in order to try to explain our philosophy about SLAs, I'm going to show the best slide that I have, that actually I didn't do it. My niece of 6 years old did it, because we have the custom in our group that whenever we have a complex issue, we want to explain it to our kids to see what they understand. And this is her idea of what is a service level agreement. There is apparently something that is automated to make the computers fall in love together. And at the end, I think it's a very nice metaphor, because as the love, the SLA is the interaction between systems is not always about functional things. No? Love is very important non-functional things, and for us, SLA is everything related with non-functionality. So I would like to give me by the way, that was my best slide, and now the presentation goes worse. So I would like you to try to, when I say SLA at the very first part of my talk, I want you to give me an opportunity to explain later on how we think that it could be interesting. So in spite that some people that are near believe that SLA could be a dead term, for us, this is something that is related with very, very actual problems, like concepts that we have just seen yesterday, like provisioning, compliance, monitoring, workload optimization, QoS, service level objectives, pricing, customizing. And actually, I just put in italics, in cursive font, because this is actually words that I heard yesterday in some talks. So just wanted to highlight that. So at the end of the talk, hopefully you will agree with me that these two concepts are really tied together. So if you want to really create an automation and some engines to optimize all the right side of the slide, you have to take into account the service level agreement. So at the very heart of our concept of SLA is quite founded in the specification that, in our opinion, was the most interesting one concerning agreements, that is WS agreement. It was a specification that at the beginning it created a lot of expectations, and little by little perhaps there has been a little lowered expectation. In our opinion, this is because of a very specific issue. But in any case, I just wanted to introduce you in one slide, just to refresh your, in case you have it in the back of your mind, what was in WS agreement. WS agreement was a specification that actually was aimed to create agreements in an automated fashion. So it provides some protocol from one agreement initiator and one responder. Initiator just asks for templates. The responder send the templates that are like agreement with some gaps in there. And then the initiator fill out the gaps between, based on his preferences. And at the end, the responder can say yes or no. It's a very simple protocol that could be extended with more negotiations, complex negotiation if you want. And also, apart from the protocol, they also specify the actual structure of the SLA. And for us, that was a very interesting thing, because before the WS agreement existence, we were working a lot on non-functional things. So it was very interesting for us to have, for the very first time, an official, let's say official for a specification, a way of put all the things that we know about non-functional in a specification. So we were very happy. But then we dive into the structure of WS agreement. That is basically context, a set of terms, and if you are a template, some constraints. I'm going to skip on, I'm not going to be very detailed because I assume that most of you know what is WS agreement. So you have a lot of terms that could be description terms about the service, like could be a WSDL or any other language, and you can have also guarantee terms, and also if you have the template, you have the constraints to make understand to the other party which are the possibilities to fill the gap between in the template. So that looked very promising. It has a lot of things, but when you go into a little more detail into the specification, then you find that there are a lot of placeholders that then are not specified. So if you want to apply this, you need to create a lot of different languages, use domain-specific languages for the very big agreement. So for us it was kind of a disappointment, because we believe that was a straightforward application. So it was not that happy moment, but it started a journey trying to create a more domain-agnostic, ready-to-use language. And just to give you an idea of why it is difficult to apply to a domain, you need to specify, you need to create, every time you use the language, the WS agreement, you need to create new languages, for example, in this case, to a grid system, to job submission, this is an example, and for constraints, you also need to specify another language. So at the end, it is a very big problem, because, well, it's not really easy to use WS. You need to create new things. So that milestone for us was really important, because it defined our research objectives, that is the results that I'm going to show you today. We tried to address two different challenges. First, to create the extensions that could be needed to have a domain agnostic, domain independent, complete language. And secondly, to create some tooling that could help to apply into a domain. Because most of the time, when you have a language, a domain-specific language, if you don't have the right tooling to validate the language, to analyze, etc., it is quite hard to use it. So that was our research goals, and I'm going to show you. We first create we create an extension that was compatible with WS agreement. We call it I agree, and we also provide not only an XML transformation to WS agreement, but also, and apparently based on the discussion of yesterday with Dr. Lehman, we were quite advanced in that moment, because it was 2 or 3 years ago, and we already defined a pseudo YAML approach to that. So this is actually what you see in the right is the actual language with all our extensions, and there's an automatic mapping into the XML WS agreement. So you can find here that is a very complete specification where you can find things like metrics, you can have temporality, you can have properties, and a specific constraint language for different terms and for creation constraints. And the most, let's say, advanced features that you can find in this language is that you can specify a very complete temporal properties within the agreement, because we believe that the temporal issues are really, really important when you take into account something formal in an agreement. So that was not present in the WS agreement specification, so you can have things like global periods, defined periods for specific guarantees, things like that. So we extend that. So, and also you have the possibility of having, let's say, a cascading of templates, like the CSS, where if you don't specify anything, a global period applied, things like that. We also create a CSP mapping in order to create an analysis of all the WS agreement, of the documents in I agree. So based on this mapping, we could create an analysis tooling, so you could really get interesting properties about the document. So, for example, we have lots of different analysis operations that, like, for example, is it valid? Do they have conflicts, dead terms? Does an offer match a template? We have several analysis operations over this CSP problem. And basically, the most important one are the validity operation, so we can check if the document is valid. For us, the semantic that we give to that is there's no conflicts, no inconsistencies during the agreement. You haven't said something in one part of the agreement and then it's a contradiction in another part of the agreement. Or you don't have any dead term. You have specified something that makes it impossible for a guarantee to meet, or doesn't apply because you have fixed it in the service description, things like that. And also the compliance between templates and agreement offers. So we have an operation that, based on an agreement, based on an offer, based on a template, it gives you the answer if the offer matches the templates or not. So we create this analysis, this library for analyzing documents, and the other thing we do was to create some modeling, a simple modeling tool, so you can write the I agree in a easy way. And this modeling I'm going to give you, uses of course the analysis library, and I'm going to give you a glimpse of what it's like, because now currently it's in a beta version, but so just to be cautious, I try to do a video demonstrating all the different features. 1 second. Whoops. I should go. So this is basically how the tool looks. It's an online tooling system, so you have different workspaces in the right, and you can specify all the different files that you have, and then you can offer, for example, an offer. We have some helping tools to specify all the different things. You can write differently. You have metrics, you have the services, the monitorable properties, and some guarantees. This is the only thing that you need to specify for the agreement. Then you can have the analysis operation, the main analysis operation as button in the top. So for example, here detect some inconsistencies because the storage size is not well defined. So if you go to the storage size, you see that you have specified your service 300 storage size, but there's a type impossibility because it's only from 0 to 200, and then you can very quickly detect typical mistakes that you can do when you're modeling the agreement. You can create new guarantees, try to specify something, and for example, let's say that you commit a mistake and do two complementary impossible guarantees, because one say you say the provider will guarantee something and the contrary, and it says this, it gives you these contradictions, so it has this kind of things. You can also, if you break the language in any way, let's, for example, let's fill in the app. Let's take a little bit forward. So you can start writing. It has some syntax checking on everything, so it has real time. It gives you explicit. We actually create a nice architecture underlined with a REST service for the checking of all the syntax and the analysis operations, and it was pretty interesting. So let's say that you analyze, you create a new guarantee. For example, I'm going to skip this. 1 second. Here. For example, here you can see that there's an option always to change into the database agreement. So you can, instead, if you are particularly adventurous, you want to write in XML, you can write it, the database agreement straightforward. You can always see the mapping between the two languages. So it's fully compliant with database agreement. And you have also the option of having different workspaces to work in different things, and the typical issues are things that you have. Also, there's operation checking with a template that it gives you the results on whether something that, for example, here there's a problem with the offer and the template because the storage size are not compliant. And you can write, you can open different documents, and at the end change it accordingly, so you are sure that the offer and the template are good together. And at the end, you solve different problems, and then if you finally solve all the problems, you have a ready to go offer. So this is kind of the tooling that we have been developing. So let me close this. So that was the first part of the talk, and that is about what we believe were the foundations and application of SLA. Let's go to the other part. So what can we do? Which challenge can we address with this tooling, this analysis, and this stuff? We believe there are quite a lot of applications actually. Because basically, with this shift to services, I don't know if you agree, but we believe that there's currently the software industry is becoming a sort of a service chain, service supply chain. No? For example, you rely on some services and you provide some services. So at the end, there's a chain. So you are a provider of some services to others and rely on services from others. So in this service chain, at the end, all these relationships, it could be really nice to have a service level agreement to indicate your responsibilities in this transaction. So at the end, in an ideal world, the world that we want to create, if you have all the relationship guided with this service level agreement that we have been talking about, you can have very interesting things, like for example the elasticity. For us, elasticity will mean something that if you want to grow, that could mean that you have new consumers that go there and want to, that you've signed agreements with them, so you need to scale. So you can detect that escalation, you can detect that you need more resources, and then that could trigger a renegotiation or a new buying of infrastructure service. For example, in a software as a service, you could renegotiate or hire a new instance, buy a new instance with Amazon. So at the end, this scalability could be guided by these kind of things. And on the contrary, if you're in a specific state and some consumer goes because that's no longer with you, it canceled his agreement, you can take that information to scale down and leave out one provider that you have. So at the end, for us, this elasticity is really a matter of what's happening with your relationship with your people, with your consumers and your providers. So the elasticity takes into account, address this problem. So the more information you have about service level agreement, the more clever your elasticity could be. So basically for us, elasticity, it's a matter of issues like concerning my provider, should I change my provider? Am I using all the resources that I paid for? These kind of questions could trigger these elasticity decisions. In terms of the relationship with my consumers, should I break my guarantees? Because, for example, I am now full and I need to decide I cannot go well with all my consumers, so perhaps I need to break with some of them. Which is the best one that I need to break with? That could be a very practical and actual decision. Or can I accept more customers? I mean, do I have the right currently infrastructure that scales to accept more customers or not? Things like that. And at the end, taking into account the whole picture, at the end, the questions, the real questions here are, what is my actual risk? What is going on? Am I going to collapse in a certain point? Am I going to violate some agreement at a certain point? Or can I be more competitive in terms of renegotiating some agreement that I have, or changing and make it cheaper, my relationship, my offers with my consumers? So all these kind of, in our opinion, very actual and practical questions that could be really automated in some way when you have an artifact like the service level agreement in a digital form that you can analyze, process, etc. So what I'm going to give you, just to state my case, is 4 examples. If I have the time, well, I have 5 minutes, no? Because we start 5 minutes later. 4 cases of specific things, works that we have in progress about availability, pricing, compensations, and SLA-driven SaaS that take this artifact as a key, the service level agreement as the main document to analyze and provide interesting answers. So we have that based on the analysis and the framework that we have. So concerning availability, there is actually one of the work where Antonio is here and has some panel in the some poster about this work. Is an ongoing work of transforming. We can transform the actual agreements in text that you have, for example, from Amazon Simple Storage Service into this template, and then we can process and to answer questions like, what if this fails? And so you can perform very clever analysis about, okay, here apparently says this is the actual real SLA of Amazon, that you have, if you have, they have a between 99 and 99.9% of availability. So the actual immediate conclusion that you could say is, well, it's pretty cool, pretty nice. But when you formalize that and you analyze the actual calculation of everything and you have it in a formal way, then you can have very fine-tuned analysis to see which are the limits of this. What does it exactly mean 99.9? So for example, in this case, actually the way of calculating is in periods of 5 minutes, and it depends on the ratio between the failed request and the request that you have done. So if you don't do any request, so that doesn't count, and then don't go into the average. So for example, there could be situations where, for example, the Amazon S3 could be stopped for up to 40 minutes in a row, failing, and you don't have any right to compensation at all, because if you don't do more requests, and that's the only things that you detected, then you don't have the availability, and you don't have the compensations. You don't have anything at all. So these things could be really this is a challenge to be addressed, to really understand what the companies, the provider, really give into. So from the customer perspective, I think is quite interesting. Another ongoing work that we have is pricing analysis. We also did it by extending our WS agreement specifications, so you can specify the purchasing options of of a customer. For example, in this case, Amazon EC2, that they have literally thousand possible options of buying an instance. And based on your load balancing, because there are basically, in our opinion, two scenarios for using a virtualized infrastructure. One of them could be, let's say, a startup that doesn't know anything about his load. Perhaps it will be successful, and suddenly they really need to scale. So they are just willing, they don't know anything about it. So you can be monitoring and then automatically detecting, now there's a peak, I need to provision. But there are also other kind of scenarios where you really know exactly what you're expecting. For example, we have a scenario of the educational system where if you want to virtualize or your labs or your computer laboratories, you really know exactly the amount of instances that you know for your groups, etc. So we have an extend and focus on those kind of scenarios where you really have a high degree of understanding of your load, your calendar, let's say, your planification of usage, so you can analyze based on this formalized way of the purchasing models, and based on your calendar with an analysis of the different pricing models and the break-even points where the different offers that they do, there's more optimal to get one type of instances use a certain load, aggregated load, and another. And you can get the actual optimal configuration that for us is the service level agreement. So you can optimize the resources that you are going to buy. Also, we have been working recently on creating the notion of compensation function, because in WS agreement was really an empty placeholder. So we have formalized the idea of compensation function as the function that have the penalties and rewards, and it creates the guarantee specify a threshold in this compensation function. So you can really have, you can analyze a lot of different properties in the compensation function, such as, am I doing a guarantee without compensations or without any flexibility, or analyze the aggregated compensation function of different guarantees, things like that. So actually it was very interesting that when we do the exercise of formalizing real agreements in document, that real agreements that you can find is, for example, was an agreement that we found from the outsourcing department of government institution. There's a template, they have a Word template that you need to file in to sign it with your providers. When we formalize it and we create all the compensation functions derived from the actual Word document into our formalization, we detect quite a lot of mistakes, because it is very easy to commit mistakes when you're doing, and perhaps you don't realize, and at the end you have a very valid document. So, for example, here we detect a very bad mistake. So we also, apart from that, we have extended WS agreement with the I agree notation, to incorporate this compensation function into the document, so you can really have everything, all the information in the same place. And finally, in order to give a more low-level details, because yesterday with the talks about Open Tosca and things that was really practical thing, I just wanted to show something more low-level. And this was a prototype that we did about what could be a SLA-driven software as a service. And so in this scenario, we have like different tenants. It's a multi-tenant scenario, and you have a system that is basically composed of different beams, no, for all the things with the Spring architecture. And the idea was that you normally have different beams together, linked together with the Spring, with the dependency. So we create a hook so you can have a non-SLA, a typical software with a Spring framework, typical one. And then once you have finished the application, you can start applying SLA aspects in there without almost touching the original source. So how we did that by specifying the idea of something we call a cloud wrapper. There was a piece of that could be configurable based on a service level agreement that you have already signed with the customer. And based on that service level agreement, you can specify by configuration new aspects that automatically take into account the service level agreement. For example, I'm going to give you a piece of code of the actual configuration of the Spring source that we have. The only thing you need to do once you have finished your application, let's say that you have this example was a veterinary, the typical pet clinic that has a Spring. It has one typical issue that you have in your software as a service is that you have a free tier that you allow maximum 100% of users. If you want to have more than 100% of users, you need to pay more, something like that. So you can have the creation of the user, for example, in the application, you have it normal, and later on you decided to create a property in the service level agreement that is maximum users. And for one particular tenant, maximum users will be 100. For another particular tenant, maximum user will be 2,000. So the only thing you need to do in order to incorporate this SLA restriction here is to create this clause. The clause basically had a chain of a validator, an executor, an actuator. And these beams, you can personalize it. For example, here, the validator is based on the database validator, so the property of the SLA will be max resources, and the searching time is called maximum of that, and then an actual sentence that goes into the database and get the number. So, for example, this is count the resources that you have in the table resource, for example, and based on this, you can actuate into the graphical user interface, and also you can detect if you have reached to the maximum. And automatically, the only thing you need to do is to grab your button, the button that adding new users, and give it an ID. Oh, sorry. Give an ID to that button. So with only this piece of code, exactly this configuration, what you finally get is that your application, based on the tenant, when a tenant reaches a maximum, automatically this interception detects that now the SLA is over in this property, and it deabilitate the button, and also say to the user, you have reached your SLA, you can go to a premium or a better offer, and this is without touching without any other code that you need. So this opens the possibility of extending applications or decouple the development of an application and the design of SLAs and how you monetize, how you are going to take advantage of the SLAs. So just to finish, my last slide is elasticity for us, just summing up, is about is quite about the relationship that you have with your surroundings and to optimize your risk and to optimize your competitiveness. And I hope you convey with me that if you have a digital artifact, a formal SLA, you can really do very clever things in this terminal. So we have doing modeling, we have doing analysis, but there are plenty of research challenges here. We can do some purchasing marketplaces, we can do scalability engines. Actually, we're working on some scalability with lean. Claiming, how do you demonstrate that someone has violated if I'm working with Amazon, how can I demonstrate that he needs to compensate me? Because it relies on you, on your responsibility of saying, hey, I need a compensation. They don't do it automatically, you have to. Or have some risk dashboards of what is going on in your organization, and several more. So, well, that was all of it, and hopefully with this analysis that we already done, all of these different possibilities could be much easier, because you have also you just have there the analysis, and then you extend it for different purposes, or you can use it for not do it from scratch. So I've got to stop. Thank you very much. If there's any question.
One of the problems now is that many cloud providers, they over provision their resources. Can you, with this, your import SLAs, can you guarantee some protection for customer, that they can be sure that they have some minimum service level agreement on the resources that they get on their virtual machines and stuff?
Well, that could be an interesting application of service level agreement that we have currently not worked on the engine that you need to take to monitor and say what are your specific levels for you. But definitely it could be a possible way of exploiting the information that you have in SLA. You have directly there the information about what the provider sent to you, and also you have your preferences about your utility function, let's say, about what is a minimum for you in order to complain or change to another provider. Then, based on these preferences, it could be possible to automate somehow the change of provider automatically if you don't reach the service level objective that you have.
It's, for example, in your example, you say the minimum number of customers.
Yeah.
What is from the provider side? Is it good for provider?
Yeah.
But maybe is it possible to do something the same for client applications, that you want to separate the request if you see that the latency like not good enough?
Well, that could be interesting. We haven't addressed that, but yes, we could have a similar. Yes, if you have a client application and you have a service, client server, no? And you have different software for provider and client, and in your client you want to incorporate. You could add these aspects to monitor things like that. You can, but you need to extend. We have a catalog of in this prototype that we built. We did we specified certain possible validators based on some monitoring issues, but normally you need to extend it to create a new validator, for example, the response time, if you were to monitor exactly. But all the comproval, all the check if the SLA met or not, you already have it. The only thing you need to do is say what is the response time, and you could have that automatically.
So you talked in the beginning about this I agree editor.
Yeah.
And it's about how to edit SLAs,
Yeah.
validating. Is it a standalone application? Is it web-based? Is it available?
Is it online? We are fine-tuning it because we wanted to create a very interactive experience. is a client rich, extensive. We use a very decoupled, all the calculating things is in the server through REST services for the analysis operations and the syntax checking and the transformation between formats. And you have a client alone with jQuery, well, with JavaScript intensive. So the thing is, we are fine-tuning it, and we will hopefully open it in for the next, let's say, few months, let's say. And we will announce it. So it will be publicly open, and everybody could have their own workspaces. It's linked with social accounts. You don't need to be accounting, and you have your private profile, and you can do all sort of things like that.
In your experience, what level of detail the providers give you about SLAs? I had a look at the Amazon SLA. It's very fuzzy in natural language. Only
Yeah.
few real level objectives are
Yeah.
implicitly stated. How do you cope with that?
Well, that's a key thing. Known. Currently, there's a first challenge that is mapping the SLA, but in our opinion, this modeling effort that you do, that provider won't do it, but there could be intermediate companies that are making some business around complementing things that the provider don't do. For example, a couple of companies that try to optimize that your contract, your billing every month is right or not, that they could really do it and give it available as a value added to create a business. But anyhow, in spite this kind of companies doesn't do that, even if you're a consumer, and it really pays off to do this modeling just for you, because you could really get a more accurate analysis, as I said, of what are your risks and everything. So one of our goals with this tool is also to create a repository of agreements, public agreements. So once someone has modeled for the first time the Amazon S3, he can publish it and also link it with the version, because actually the other things that have Amazon is they change it every month or every 2 months. So that's also very interesting to have it formalized, because you can really check exactly which are the changes, because most of the time when they change it, you don't really get a mess because you don't know exactly what changed. But when you have it already formalized, it's really quick to see everything. So our view is that will be a community-driven modeling approach, not by providers, or perhaps some companies want to create intermediate services.
Okay, so I think thank you for your talk, and then okay, so our next speaker will be Holger Swart from University of Stuttgart, and